learn about the properties of microwaves, the advantages, the disadvantages of microwave signals, and few of the applications of a microwave signal, and a little introduction about the microwave vacuum tube devices. Okay, so coming for the properties of microwaves. Basically, as you all know, a microwave signal is an electromagnetic signal which can emit its radiation with short wavelength. This is one of the major important property of a microwave. And also a microwave signal can reflect by conducting surfaces just like optical waves as they can travel in a straight line. And whenever a microwave signal is propagating, we also call it as microwave current. And whenever the microwave signal is allowed to flow through a conductor, then the current flows in the conductor. It should be a thin linear structure. And one more important property of a microwave is microwave signals are easily attenuated within short distance. So, due to this reason, always we try to make use of the microwave signal where it should transmit for longer distances. So, that's the purpose why the microwave signals are used for longer distances where antenna would be one of the radiating element. And one more important property of a microwave signal is they are not reflected back by ionosphere. As you all know, a signal cannot propagate through ionospheric layer very easily. It needs a higher strength to propagate through the ionosphere layer. But a microwave signal can easily propagate through the ionospheric layer, and that's the reason why they are not reflected back. So these are the important properties of a microwave signal. And coming for the advantages as well as the limitations of a microwave signal. The main advantage is as the microwave signals are high frequency signals, which is in the order of megahertz to gigahertz. Always the increased bandwidth availability is high. The bandwidth availability is high in a microwave signal. So one major advantage of a microwave signal, that is when you are making use of a microwave signal for any application, yes, it provides high bandwidth. Okay, so the main advantage is microwave signals have larger bandwidth compared to the common bands like shortwave and ultra high frequency waves. So for example, whenever we are talking about a microwave signal, the wavelength of the signal is 1 centimeter to 10 centimeter. If it is between 1 centimeter to 10 centimeter, then the frequency of operation would be 30,000 megahertz, 30,000 megahertz to 3,000 megahertz. And the bandwidth would be 27,000 megahertz. And the second important advantage of microwave signals are their ability to use high gain directive antennas. So normally the medium of transmission for a microwave signal are the structures used are different. Means whenever we want to allow the propagation of radio frequency signals or microwave signals, we make use of the structures called as waveguide structures or antenna structures, which can allow the transmission of the radio frequency signals. So, if I take that into consideration, the antenna is one of the major device, the electromagnetic device, which can transmit and receive the radio frequency signals or the electromagnetic signals. And as the antenna can withstand the radio frequency signals, the directive antennas can be utilized so that the directivity of the antenna is improved whenever we focus on an electromagnetic wave. That is second advantage of the microwave signal. One is increased bandwidth, and the second one is improved directivity. And the third important advantage of an antenna is whenever a signal propagates through atmosphere, normally the effect of fading is high in if it is a low frequency signal or is a just a high frequency signal. But when we are making use of a radio wave frequency signal or is a electromagnetic signal, the effect of fading is less and it varies depending upon the signal strength and the reliability of fading is also available. Okay. So when you are talking about this, you need to correlate this topic with the layers of the Earth. It is stratosphere, troposphere, atmosphere, and ionosphere. Okay. So the fading effect on the signal due to the variational transmission medium is more effective at low frequency. But a radio frequency signal is a high frequency signal or is a very high frequency signal. So the effect of fading is very negligible for a electromagnetic signal because the major reason is the signals can travel for longer distances and at higher altitude and with great speed, with higher speed. That's the purpose why the effect of fading is less for a electromagnetic signal. As the height increases, the fading level decreases. And second one is whenever we are talking about the line of sight propagation at higher frequencies, the fading effect in a microwave communication is reliable. Means to say that, for example, if I take an antenna as the element which is transmitting the radio frequency signal or is a microwave signal, I can move the position or else I can position the antenna in a different at a different angle so that the effect of fading is reduced. If I come across that if the signal is propagating in this direction, the fading level is high, then whenever the angle of the antenna inclination or transmission is changed, then during that time, the fading effect could be reduced. So this is the third advantage of the microwave signal. The fading effect is less and it is reliable. We can eliminate. Next, power requirements. Actually, this is one of the thing which is plays a major important role in any communication. So in a microwave communication, normally here also it consists of a transmitter and a receiver, but the power required for the transmitter and receiver to operate is pretty low at microwave frequencies compared to a short wave band because the electromagnetic signals or the radio frequency signals is available in nature itself. So due to that, the power requirement by that particular device is less. And the next one is transparency properties of a microwave. As you all know, the microwave frequency band is between 300 megahertz to 10 gigahertz or 300 gigahertz. They are capable of propagating freely in the atmosphere. So there is no barriers which can stop the propagation of microwave signal or the radio frequency signal to atmosphere or in free space. So that's why we call it as transparency properties of microwave. It is easily the microwave signals can easily penetrate through the different layers of atmosphere. So it is possible for us to track the things which is in darker zones also. So that's why we make use of a microwave signal in radar systems. So as the transparency in a microwave is more, the microwave radiations from the sun and the stars can be studied easily in a astronomical research center of space. Okay, so this is one of the application due to the transparency property of a microwave signal. Next, coming for the applications of a microwave signal. Where do we find the applications of a micro signal? There are various areas or as various regions where the microwave signals are useful. The first one is in telecommunication. So whatever the signal that is propagating by in a mobile phone, they are, or else in a telephone, they are all micro signals or else they are all electromagnetic signals. So the intercontinental telephone system, the space communication system, and all telemetry for communication links for railway will make use of this microwave signals. So the first application of a micro signal is in the area of telecommunications. The second application is in radars. So can one of you tell what is a radar?
Radio navigation and training.
No. Slight modification required. You studied this in your second PU 10th, right?
Yes, ma'am.
Radio is correct, but navigation it's wrong.
Radio and
Uh,
detect. uh,
radio
Radio detection and ranging, ma'am.
is very good. So it is radio detection and ranging. So detection means to say that first of all, whenever you transmit a radio signal to the place wherever you want to detect something, first the detection of the object takes place. And ranging means say that it calculates at what exact distance, at what which place the object is located. The best example is you can take the aircraft as an example. Whenever an aircraft takes off from the uh, airport, then the tracking of the aircrafts are done using the radar signal. So we will know where exactly the flight is located and what's the distance that the flight has traveled away from the airport. Okay. And one more thing is as we are making of the electromagnetic signals, they can propagate for a higher altitude with greater speed and moreover the signal to noise ratio will also be less over there. So due to that, the detection of the aircraft takes place easily. So that's why we call it as radio detection and ranging. The use of radio frequency signals to detect a object and calculates is range. Range means to say in radar concept it is distance between the transmitter and the receiver. Okay. So in radar applications also, we make use of a microwave signal that is particularly for detection of aircraft or else we can also track the missiles in Navy and the weather patterns can also be observed using the radar signals. That is where the electromagnetic signals or else micro signals are used in radar systems. We also make use of this in air traffic control, the garage door openers, the speed detectors and all. These are the various applications where we make use of the microwave signal or the radio frequency signal for practical applications. We also have few of the applications in relevance to commercial and industrial applications. Okay. So the third important application of a microwave signal is you can find it in oven. We have a microwave vacuum device which will be placed in a oven so that whenever you keep some food in the oven, it gets heated up or is the food is heated within 2 to 3 minutes. So fast. And even in drying machines also. Dyeing machines also, we make use of this radio frequency signals or its microwave signal that is in textile industry, food industry and paper industry. Whenever we want to dry the items at a other voltages, then this high power, whichever we have in the microwave frequency, the microwave range, they will help to process all this. Drying of cloths in textile industry And we compare in food industry, if you want, whenever the potato chips are manufactured and it has to be packed, before that the micro frequency signals will also help in drying those things, and even printed matter also. And next, even in food process industry also, we find the applications of microwave signals, where it is used for pre-cooling, cooking, pasteurizing, sterilizing, refrigerating, roasting, and all. Okay. Even we find the application of micro signals in rubber industry, plastic industry, and other applications like mining, public work, boring of tunnels, breaking of rocks, everything. And the other biomedical applications are, we make use of the micro signals for electromagnetic eating treatment of cancer, that is hyperthermia, where whole body for cancer therapy is utilized, is done, the progress is done, the testing is done using the microwave applications or as the radio frequency applications. Okay, but here they cannot make use of the X-ray. Instead, they make use of a microwave or as a radio wave. There are few more applications in combined. That is, if you want to just classify it at an outlet, then the application of microwave is also you can find in wireless communication. That is, our mobile phones, that is cellular phones, whatever we are using. There we have a microwave signal, and in cordless phones also, where you connected by means of Wi-Fi, even they make use of microwave signals, and even Bluetooth, etc. And in radar and navigation, this is used in airborne vehicles, and it is also used in weather forecasting and GPS, that is global positioning system. Also, we are making use of this RF signals or as micro signals. And we also, the application is also found in remote sensing. Remote sensing means in meteorological centers, land surface, marine traffic, that is submarines. Whenever marines are moving, and then whichever is submerged in the ocean, there should be no clashes between one marine to the other marines whenever they are under mobility. So the remote sensing concept, which makes use of the microwave signal, is the one which helps to monitor the traffic of the submarines under the ocean. So that is one of the advantage which any other signals in the RF spectrum cannot do it. And next is RF identification, that is toll collection. Yeah, the RFID tags, just by the RFID, the toll collection could be done, tracking of animals, everything. The security also, we make use of micro applications. Next is in relevance to broadband, the AM and the FM radio, the television, whichever we have, all those make use of the radio frequency signals. And biomedical application in diagnosis, that is treatment of cancer. And for eating, it is baking, ovens, drying machines, mining, rubber industry, and all. They make use of microwave applications. Okay. Any clarifications with this? So until now, I covered with these topics, that is properties of microwaves, advantages and limitations of microwaves, then finally the applications of microwave. Okay, so in the communication lab, we are conducting the experiments relevant to microwave also. It would be one of your Viva questions. What are the applications of micro signals? What is the range of micro signals? And what are the properties of micro signal? Or else, what are the applications of micro signals? Okay, so this would be possible questions for your Viva. But this is a basic knowledge when you are studying the micro signal.